Great. And for our next talk, we have Chayim, Kirshen and Meir Shpilraien. So, chasing birds with code. The floor is yours. Thank you.
Cool. Hi, everybody. I'm Chayim. This is Meir.
Hi, everyone.
And this is what we do. Meir?
Hi, everyone. My name is Meir. I'm software architect at Redis. I like coding, play video games, and before I worked at Redis, and before that I worked at Redis, so basically I worked at Redis.
I'm Chayim. I also work at Redis. I work on the Redis clients. I manage that team and our automated testing. I've been using Python since 1.6, and I originally come from Canada, so I've done just like 16, 17 startups now. It's a long run. So I'm X like everything. So I don't know if you have this problem with birds here, because I'm not from here, but in Israel we have a big problem because they're pretty and we love them, but they take over our balconies and there's very, very little space, right? And then we have this invasive bird called the myna, which isn't from Israel. It attacks other birds. Basically, it kind of sucks. And I'll just say no one likes cleaning up after birds, right? Let's call it like it is. So we wanted to get rid of birds in a nice way. We wanted to do it, first of all, with software, because that would be very cool. Second of all, we wanted to disperse them. They should go away. We wanted to know what the birds are. And you need machines. You need Raspberry Pis, which, that was hard to get. I also don't know why this slide is here. So here's how this works worldwide, right? You either have these horrible spikes that, they're just kind of mean. They're made of metal, or they're made of plastic, so you pollute the planet. It's not cool for the birds, right? It's really just not okay. I don't know about here. In Canada, we have scarecrows. Those don't work at all. Who are we kidding? And then I haven't seen this anywhere else, but the part of Canada that I'm from, the dead middle where you grow all of the wheat, they're gigantic cannons. And you fire buckshot into the air, which scares the birds away, makes a huge noise, but it kind of sounds like you're in the middle of a war zone. It's not okay. It's really not okay nowadays, right? So, honestly, we write code. Why not take a Raspberry Pi and a camera, figure out how to identify birds in real time? We work at Redis, so let's go use Redis to do that, because Redis is super, super fast, and he's going to tell you why, because I suck. Let's use different speakers. Let's make noises. Let's use Python, and let's do it all in real time with software, because we can, and we should over-engineer things, right? So from an architecture perspective, here's how it works. I'm going to call this very classic. You have a computer. It has a camera. In our case, the computer is the Raspberry Pi, so you can't get those for another year or something. The Raspberry Pi notifies Redis Gears, which is a capability of Redis. It has an AI module that we use, an AI capability nowadays, that helps us identify that it's a bird or not a car, that sort of thing. Store things in Redis, so this is hyper, my version of real time is not this within 5 minutes we mean real time, within 15 seconds we mean real time. Real time means hey, this is real time. I said the word real time, it's now. And the end of the day, you do the lazy thing. Redis Gears, as Meir will tell you, is a processing engine, ultimately. So it fires off an HTTP request, because I'm incredibly lazy and could do this in 2 lines of code. The Raspberry Pi receives the HTTP request, looks for a file on disk, and says, cool, I can just throw that out a speaker. I couldn't figure out a lazier way to do this, to be honest. Then the birds go away, which is really cool. And this is because we wanted to update our team on how this was going. So that's a webcam? That's your webcam?
Yeah, that's the webcam.
Nice. So that's a webcam. That's Meir's balcony. This is a bird. And that's why you don't buy it's not you don't buy. The $5 Raspberry Pi camera is very pink by default until you run it through filters. All right, this is you.
Thank you. Okay, so we decided to use Redis in order to identify the birds in the image, and they decided to fire some sound to scare them away. So why we use Redis? We use Redis basically because it's easy. It's easy. We start it works. We basically almost zero configuration that we need to do. Anything is just working, and it's nice and easy. It's fast. We need fast, as Chayim mentioned, few times. We need real time.
So, you guys have used Redis, right? Some of you?
Yeah, who used Redis? Raise your hand. Oh, nice.
Oh, nice.
Yeah. So it's fast, and in the latest version of Redis, we also have the stream data type, which I will talk shortly, and it allows us to really do the real-time processing. And as Chayim mentioned, we have a module, a capability that allows us to do AI processing inside Redis. So we could analyze the image inside Redis without getting it out from Redis to be analyzed on the client side, for example. So, anybody heard of streams in Redis? Raise your hand. Oh, not a lot of people, so okay, I'll say what it is. Basically, Redis streams is a new data type that was added not recently, like maybe 2 years ago, I think, to Redis, and it allows us to analyze and not analyze, but store a log, but this log doesn't have to be a log of the text log, it can be anything that we want. So in our case, it's the images that we want to process. And it allows us to process this in real time. The moment that the data is getting into the stream, we can take it from Redis and analyze it and see, and analyze the picture and see what's we have in the picture. And as we said, we have AI capabilities. It's called Redis AI. It's a module that you can load into Redis, and it allows us to do AI processing on tensors and basically the images, right? The images that we can translate into tensors. It also allows us to run in a CPU or in a GPU, whatever we want, and it runs inside Redis. So we basically the moment that we get the image into the stream, into the Redis stream, the image doesn't have to be taken out of Redis. Everything is done inside Redis. Now the question is, how do we do it? Because the image is getting into the stream, and we need to somehow tell Redis, take this image, maybe resize it, maybe change it a little, and then give it to the AI model to be processed. And for this, we have two options. Either we take the image out and then resize it. But this is not a good option because we want to do everything inside Redis. So we used Redis Gears.
Which is his baby, by the way.
Yeah,
he wrote Redis
disclaimer,
Gears.
I wrote Redis Gears. Who heard about Redis Gears?
Okay, me.
Thank you. So basically, Redis Gears allows us to run our logic inside Redis. Instead of getting out the data and do the logic on the client side, we can send the data to Redis and do the logic on Redis. And in our case, it's perfect because we don't want to take the images out of Redis. It's a lot of network hop, it's a lot of network that we need to pay in order to take the image out and do the processing and the logic. So instead, we send the logic to Redis and Redis runs it. And I will show you a bit of code how we do it. Moreover, Redis Gears and Redis AI, great match because they are working perfectly together. They were built, so once they are both loaded into Redis, we can directly call from our Gears logic to Redis AI and use Redis AI directly without any data copying, any network, nothing. And of course, we are at PyCon, so Redis Gears allows you to write your logic with Python, and it runs an embedded CPython interpreter inside it. So, you're ready to see some code? Oh, and of course, I forgot the bottle. This is the small HTTP server that allows us to connect back to the Raspberry Pi and tell the Raspberry Pi, please make some noise. We saw a bird in the image, and you need to scare it away. You ready to see some code? Oh, good. Okay, so
He said you'd see code.
This, of course, I'm not going to go over the entire code. If you want to come to us after and we can talk and discuss, you are welcome to. In our case, we use a model called YOLO. You only look once, if I remember correctly. And this model is already a built-in model, and it allows us to identify the birds in the images. And you can see that this code basically runs inside Redis Gears, inside Redis without any network, and it allows us to take the image, open it using and then pass it to the Redis AI. Here we have the exact API that we call Redis AI. This API is not something that is available in any Python library. It's when you run inside Redis Gears understand that you also have Redis AI loaded, and it gives you this API by default.
And it's running on standard Python objects. Like what we're doing is we're taking the image and condensing it down to a NumPy array, and the NumPy array is what goes through Redis AI. So like as a Python developer, you use NumPy, use scikit. This is everything we do all day.
Yeah. In this case, we use TensorFlow in order to run the AI model, the YOLO. And then we use PyTorch. Redis AI comes with multiple AI engines that we can use. So after that, we use PyTorch in order to analyze the results from the model and create boxes and understand exactly in the image where the bird is located. And after that, we were able to paint the boxes on the image and show the image with the boxes and see exactly where the birds are located, and of course sends a REST API to the Raspberry Pi back to make noises and scare away the birds. Now, how we took images, this is also interesting because we are familiar with the CV2? No? Okay. So it's easy to take images from my camera in my laptop. This is only I need to use the zero, but it's really, really hard to capture images from an IP camera. It's hard because the manufacturers and it depends on the camera type, and nobody gives you the exact URL that you need to use, and you need to dig into details and understand how to use it. But we figured it out, and eventually we were able to get images from our IP camera. So this is not a very hard code, but what it does, it takes the frame, it takes away some frames, depending on some configuration, because if we were not able to analyze the frame fast enough, then we dropped some frames. But it was good enough to analyze the picture from the IP camera and see that there is a bird in it. And then we send it with the time, so we can understand how many frames we can process per second. And it was very fast, by the way, at least with the first model that we use, but I'll talk about models after, about problems that we had. And this...
That's my problem. Cool. So how many of you guys have used Bottle before? Or know Django and other frameworks? So Bottle is pretty much the laziest HTTP server you can write in Python. What you don't see is you've got an if main. Congratulations, you have all of your routes defined. It loads routes via a decorator. So I wanted something that returned to 200, which isn't OK, because I absolutely screw things up and would like to be able to curl my web server. And the second function is the part we actually care about. My original thinking when I over-engineered this was download lots of sounds, throw them in folders. Then let's have it randomly start to figure out what sound chases birds, because we could analyze things at both sides. So let's randomly pick a sound. I mean, lightweight random, random not in choice, not real random. And so we randomly pick a sound from a folder, randomly play it, and let's see, do birds like owls? Do birds hate my children? Like, there's something in there. Hint, I don't know if they hate my children. I do know they don't like owls. So that's kind of cool. And running it on port 5000, but also being lazy because it should never run on something else. Like, this is not over-engineered as much as I would like. This is the laziest way I can do this quickly. So, I don't know, you've all seen Star Trek. Nothing ever works, right? Here's what nothing ever works means. We couldn't get, hey, Raspberry Pis. That was fun. We started with the 2B because that was the only model available in the country. That was fun. I happen to have a Raspberry Pi 4 because I built a, what's it called? A RetroPie, like those little Nintendo things, and have like 15,000 ROMs on my server inside of my house. So now my kids can't play video games, which is probably healthier, to be honest with you. So the Raspberry Pi 8, great. Raspberry Pi 2 didn't have Wi-Fi, wasn't fast enough, but you could capture 15 frames a second, no issue, in 1 gig of memory. So that tells me, like, with the Wi-Fi card, that would have actually worked out pretty well. Like 15 frames a second is good enough for this, frankly. Also bought a USB Wi-Fi extender that didn't work with the built-in kernel that was available for that. I'm just, like stock. Let's put in, turn on, free OS, not think about this. Turns out that was a bad idea. Other things we ended up finding out, frankly, we couldn't run everything there at the time, so we offloaded it to a desktop. You can run all of these things on actual Raspberry Pis. It was more a matter of I have something with 1 gig of RAM. You're not going to run anything real on that workload. But it was fun. As Meir mentioned, we started with a model called Tiny YOLO, so that is a smaller YOLO model with fewer things. Turns out that sometimes birds are cars. Learn more. You've got a bigger sample. Not all birds are cars when you move over to a better model. There were some config changes. So to be honest, I could run a Debian because that's what they give you, or I could run in Ubuntu because why not? Full disclosure, I run Manjaro if anyone cares about Linux games. So put Ubuntu on the Raspberry Pi. Fantastic. Doesn't actually support any of the legacy camera APIs that you need. So lesson learned, if you want to do something out of the box and just kind of flow with everything that's out of the box, you go with out of the box. We went with the standard Raspbian Debian image that Google Raspberry Pi, click the download button, no brain power used, all my fault. Like I said, the default OS had wireless issues, so then we moved to the Raspberry Pi 4, works out of the box. And network design, we originally wanted to do everything in an all-in-one on this one machine, ship it. Didn't have the processing power because that started with not having the hardware. And then at the last minute, we also switched cameras to Meir's streaming webcam. What was really cool, what you saw 2 slides back, bop, 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 4 slides back, is because we use OpenCV and because there's an RTSP stream there, that means that this is completely open source standard protocols, which is great because you get support, you don't have to think. There's unlimited ability to read up on these things, which is the part that matters most. And then this is what it looks like when you're
This
not...
is my balcony, by the way.
Yeah.
And
there are nice trees here. Israel isn't...
we have a nice sun in Israel. So.
Yeah. It's not only a desert. I thought that too before I moved there. So that's real time, right? Okay, now let's do real time. You want to? I don't know how to use computers today. What's it? You click at your computer. It's okay. My Linux doesn't really have a GUI. It's sad.
Okay, so future improvements. We want to analyze the birds that is in the picture and maybe make a different sound based on the birds. We want to improve performance because, as Chayim mentioned, we started with a Tiny YOLO. Tiny YOLO it recognized humans very good, so we tried it on ourselves and we saw that, oh, nice, it's working. But then the bird came and nothing happened. It didn't recognize the bird.
We also didn't have birds. That sucked for an entire day.
Yeah, it's a Murphy law, right? I have birds all the time in my balcony, and when he came, the bird didn't come. So.
Yeah. But lunch was good, no?
We waited a lot of time to catch this bird, and when we moved when we moved out from the Tiny YOLO, that didn't work with birds. We moved to YOLO, and then the performance was decreasing. We were able to do 1 frame per second. So we want to see how we can improve the performance. Either we can use the GPU or we can use parallel processing and parallel the image, parallel the processing and analyze it in parallel. You want to say something on this slide?
I have something that's not here. In my over-engineered world, I do have a solar panel that could power my Raspberry Pi, which is great, and a motion sensor, and you can get all of those things on Ali for 5 shekels. Let's call it $1. That's kind of shockingly free. That's 100% something I'm going to do, by the way. Just leave it outside and let it live the dream.
So you can get into those links. It contains our code. It contains Redis Stream, Redis Gears, and Redis AI documentation. You can read about it. You can talk to us. And I guess we can see a demo.
Yeah. It's all open source.
Yeah.
I think the top is Apache licensed. I think. I didn't write this. This is before I joined Redis, right? It's a cat demo, so replace cat with the local pest. We used birds. The rest are docs, tutorials, ship it.
Yeah. Okay, so I hope it will work. So I will start a Redis server, as I said, and I'm loading the the Redis Gears module, the Redis AI module, and on Redis Gears I also tell it to load the Python plugin that allows me to run Python inside Redis.
And not hyper-optimized because it's the CPU.
Yeah, it's the CPU.
So this is
one core, one thread. So, and this is the tiny YOLO, by the way. And we change it to recognize human because we don't have birds here. So you will see how it recognizes humans. I'm starting it. You can see that Redis Gears was loaded correctly, and Redis AI was loaded. And also you can see that the REST API that I use in my simple GUI and not so pretty GUI is running inside Redis. Because it was easy, it already runs Python, so I can start a REST API and show you the images. And I said we will try to recognize humans. So Chayim, according to his title, is human.
I am actually a human, that is my title.
And if you stand there, maybe we'll see that it's working.
Ooh, we didn't try this at distance, this is fun.
I hope it will work.
Remember,
Yeah.
what can go wrong will, people.
Okay. So
All right.
you see it, right?
Yeah.
It's actually recognized.
In real time, but I'm going to step out of frame.
Yeah.
And now I'm just going to dip in my head. This worked earlier.
Try to yeah.
There you go. Okay, you need a body.
And this is the tiny YOLO, so it can do a lot of like you see there are 40 frames per second. When we drop to the regular YOLO, it was dropping to 1 frame per second, but I guess we can improve it and make it much better.
Yeah. Also, really low memory usage, which is kind of cool. Like we're talking about non-existent hardware nowadays.
The memory is increasing because we're recording. What I did is we're recording 1 minute for 1 minute, and then we drop the images. And I did it so we can catch the birds, and then I will press save the recording, and we'll have it. This is the simple movie that you saw before.
That's it?
Yeah, if you have questions.
You guys have to ask questions now. That's your role.
Yeah, great. Thank you. Very interesting presentation. We have time for a few questions. Yeah.
I can try to speak up.
Sure. I mean.
Thank you guys for a very nice presentation. Thank you. I was thinking that bird watchers would really love to have this in their kitchen window to see if there's any rare species coming to visit. And basically it would just take a short video whenever there was a rare species.
I could totally see that. I mean, to be honest, this is the sort of thing that has a lot of applications out of let's get rid of the birds we don't like. I totally agree with you. I also really like not using spikes. I have to be honest with you. Those kind of bother me.
By the way, it's really easy to recognize a different object because it's just changing one line in the code, and because basically the model gives you where the object located and what is the object, and then we filter it out on the Python code, and we say, I want to only know about birds. So if we want to recognize different animals or different objects, it's really easy, and it can be done really easily.
Cool.
Thank you. I had a question. Is there a way to manage packages in Redis Gears?
Yeah, you can, when you upload your Gear script, you can say, I want, you can list the requirements that you want to be installed. You can say if you want it on a virtual environment or you don't want it on a virtual environment, and then everything is installed automatically, and you have it with packages. You saw that in our code, we used the CV2, which is external package, yeah. So definitely possible,
And Python version as well?
Today, Gears is Python 3.7, 3.7.12, I think. Gets upgraded like everything else.
Basically, we want to upgrade it to the latest. We have some difficulties, not because of Python, but because of the way we implement it and we save the code. But we will figure it out, and we will find a way to upgrade the version.
Yeah. And the underlying Redis libraries that Gears uses to speak to Redis, since that's what we do, does work with Python 3.11. Actually works with like what looks like 3.12 could end up being, which is, I just assume, but you never know.
Thanks.
Thank you for the talk. I would like to ask how easy is it to set up TensorRT environment on Redis gears, if you know TensorRT?
We didn't do TensorRT. We have PyTorch, Onyx Runtime.
Yeah.
We don't have an AI backend in Redis AI today for it. We're always looking at things. So honestly, I would actually say if you go to the Redis AI repo and add a GitHub issue, I guarantee you that someone will look at it, Devere, and probably me. But yeah, honestly, if people need it, let's figure it out.
Because it could help with the speed, because YOLO, like big YOLO runs pretty fast with TensorRT, from my experience.
Cool. Thank you.
There is time for one last question if someone wants to have one.
So with Redis streams, when it comes to the data management, if you want to, for example, birdwatch and record a lot of stuff, how are there any good APIs or tools to manage data retention and sort of, purge old data? Since it's append only, I guess you could end up with a lot of data if you're not careful.
We should talk about how streams work.
Yeah, so
the Python library is awesome. I'm saying that as the person whose team it is.
We use Redis Gears here. Redis Gears comes with support for Redis streams, and it allows you to say that I want to read the data from the Redis stream, analyze it, and once you hack it, that you were done with it, Redis Gears automatically will delete the data from the stream. So basically, everything that was processed is automatically deleted. And if you want to save some images, like I did in my simple and UI, then you can tell Redis Gears to not delete this specific image or this batch of images and then save it. So this is solved on Redis Gears. Yeah.
And since Gears is that computational engine, I guess ultimately it's up to you to do whatever you want with it. One of the things that we do is like RGSync, right? We have people who throw data into Redis, and we have a right behind Python module that then rips things back to MySQL, for example, because that's what their need is. So it's a completely different use case of the exact same technology.
Great. Well, thank you again.
Thank you.
Cool.
Thank you very much.
Thank you. Thanks, everybody.